What's up guys, this is Massey. Welcome to another video. In this video I want to show you some examples regarding solving logarithmic equation. First example I have is log x plus 4 equals to 1. We need to evaluate x. How do you do it? We can say the base is 10, so we can say x plus 4 equals to 10 to the power of 1, which is going to be 10. So x will be 10 minus 4, which is going to be equal to 6. Next one. Log 2x minus 3 base 5 equals to 2. I'm going to say 5 to the power of 2 will be equal to 2x minus 3, which means that 2x subtract 3 equals to 5 squared, which is 25. Therefore, 2x equals to 25 plus 3, or 28. So x will be 28 divided by 2, which is going to be 14. Next example. Log x minus 1 subtract 1 equals to negative log x plus 2. This example, I need to move this part to the left hand side and move negative 1 to the other side. So that will be log x minus 1 plus log x plus 2 equals to 1. And then we can use the product rule and multiply these two. And that has to be equal to 1. In other words, 10 to the power of 1 equals to this one. So that's going to be x subtract 1 times x plus 2 equals to 10 to the power of 1, which is going to be 10. So we have x squared plus 2x subtract x minus 2 equals to 10. Which means that x squared plus x minus 12 equals to 0. When you factor it, you're going to have x plus 4 times x plus subtract 3 equals to 0. So x can be negative 4 or positive 3. Let's see if we can accept them. X minus 1 and x plus 2 has to be greater than 0. If we use negative 4 in here, this one is going to be negative, and also even this one is going to be negative as well. So x equal to 3 is the only acceptable answer. Next one. Log cube root of x squared plus 48x equals to 2 over 3. So we can say log x squared plus 48x to the power 1 over 3 equals to 2 over 3. Which means that 1 over 3 times log x squared plus 48x equals to 2 over 3. And if we multiply both sides by 3, we can say log x squared plus 48x equals to 2. When we evaluate it from logarithm to exponential, it's going to be 10 to the power of 2 has to be equal to x squared plus 48x. Therefore, 100 equals to x squared plus 48x. So x squared plus 48x subtract 100 is going to be equal to 0. So we have x plus 50. When you factor it, x subtract 2 equals to 0. So we have x equals to negative 50 or positive 2. Now we need to check that which one is acceptable, which one is not. As you see here, this expression has to be greater than 0. If we subtract positive 2 or if we subtract negative 50, in any case it's going to give you a positive answer. So I'm going to say both roots are valid. Next example. Log x subtract 2 equals to 1. I'm gonna say x minus 2 equals to 10 to the power 1, which means that x equals to 2 plus 10, and that's gonna be equal to 12. Next one, 2 equals to log x plus 25. That's gonna be 10 squared equals to x plus 25. So x will be 100 minus 25, which is gonna be 75. Next one is 4 equals to 2 log x plus 62. If we divide both sides by 2, I'm gonna have 2 equals to log x plus 62, which means that 10 to the power of 2 equals to x plus 62, and we can say x equals to 100 subtract 62, and that's gonna be 38. Next one is 1 subtract log x minus 7 equals to 0, which means that log x minus 7 equals to 1, which means that x minus 7 equals to 10 to the power of 1, and x will be 7 plus 10, and that's going to be equal to 17. Next example. Log x minus 8 equals to 2, which means that x subtract 8 equals to 10 to the power of 2, which means that x minus 8 equals to 100. So x will be 100 plus 8, which is going to be 108. So x is 108. Next one, 6 subtract 3 log 2x equals to 0. We can say 3 log 2x equals to 6. So log 2x equals to 2. So we can say 2x equals to 10 to the power of 2, which is going to be 100. So x will be equal to 50. Next example, log x plus 4 base 3 equals to 2. You can say x plus 4 equals to 3 squared, which is 9. So x will be 9 subtract 4. That's going to be equal to 5. Next example, 5 equals to log 2x minus 10 base 2. It's going to be 2 to the power of 5 equals to 2x subtract 10, which means that 2 to the power of 5 is 32. 2x subtract 10. So 2x will be 32 plus 10, which is 42. So x will be 21. Next example, 2 subtract log x subtract 11 base 4 equals to 0. So log x subtract 11 base 4 equals to 2. So 4 squared equals to x subtract 11. 4 squared is 16, x subtract 11. So x will be 16 plus 11, that's going to be 27. Next one, 9 equals to log x plus 100 base 5 plus 6. You can say that 9 subtract 6 is going to be 3 log x plus 100 base 5. So 5 cubed equals to x plus 100. So we have 125 x plus 100. So x will be 25. Next one, log x subtract 1 base 8 plus 1 equals to 0, which means that log x subtract 1 base 8 equals to negative 1. So x subtract 1 equals to 8 to the power of negative 1, or 1 over 8. So x will be 1 plus 1 over 8, or 9 over 8. Next one, log x squared minus 3x plus 5 base 3 equals to 2. So we can say x squared minus 3x plus 5 equals to 3 squared, which is 9. So x squared subtract 3x minus 4 equals to 0. Then when you subtract it, it's going to be like that. So x is going to be 4 and negative 1. We need to find out which one is acceptable, which one is not. When you subtract here, and when you sub here, 4 squared minus 3 times 4 plus 5 is going to be 16 minus 12 plus 5. That's going to be 21 minus 12. That's 9. That's acceptable. Negative 1 squared subtract 3 times negative 1 plus 5 is going to be 1 plus 3 plus 5. That's going to be 9 as well. So it means that both answers are valid. So here are some basic examples regarding solving logarithmic equations. I hope you enjoyed this video. Please don't forget to subscribe to this channel. You can have access to many other videos regarding logarithms and other topics in math, chemistry, and physics. Thank you for watching and have a great day.